In this video, we're going to prove the standard divisibility test for 9. Whether it's not the standard proof, you decide on your own, but the method is pretty standard. It says add up the digits, and when you divide the sum of the digits by 9, if 9 divides the sum of the digits, then 9 divides the number. So we're going to let n equal some number, some integer in standard form, and we're going to let s be the sum of the digits. And then of course I want to show that 9 goes into the integer n if and only if 9 goes into the sum. So how about we get into this? How about we define f of x to be a sub 0 plus a sub 1. So basically, this expression here, where 10 is replaced with x. So positive or integer coefficients, positive digits for the coefficients, digits. a0 plus a1 x plus a2x squared, all the way up to am x to the m. Okay, now p of 10 is going to be a0 plus a1 times 10 plus a2 times x squared plus am times 10 to the m. But that's n. I defined it in here. That's n. Okay, and also p of 1 will be a0 plus a1. That should be oh, something's wrong here. Right here, p of 10, it should say a sub 2 10 squared. And defined p of 1, I use that formula. It's going to be a0 plus a1 plus a sub 2 all the way up to a sub n. Because 1, 2, if you replace x, you're always going to get 1 to a power, and 1 to a power times the number in front is just going to be that coefficient. And turns out that this here is the number s. This is s from the definition in the theorem. Okay, now note that 10 is congruent to 1 mod 9. 10 minus 1, 9 divides it. 10 minus 1 is 9. 9 divides 9. 9 goes into 9 exactly one time. Well, this implies that p of 10 is congruent to p of 1 mod 9. Okay. Now, let's see. If this is true, what is going to follow? I just want to think about how to write it up. Well, I mean, this says that because that's n and this is s, it says n is congruent to s modulo 9. Well, this implies that our 9 divides n if and only if 9 divides s. That's what this statement says. 9 goes into this number if and only if 9 goes into s. 9 goes in here if and only if 9 goes in there. Does 9 have to go into n? Absolutely not. 9 does not have to go into n. But I'll tell you one thing. If 9 doesn't go into N, 9 won't go into S. Because 9, N, and S leave the same remainder when you divide by 9. But when 9 does go into N, and that's what we want to find out. When does 9 go into N? Evenly. 9 goes into N evenly. That means it has no remainder. So if N has a 0 remainder mod 9, then S also has to have a 0 remainder when you divide by 9. That is, 9 goes into S as well. They both happen at the same time. That completes this proof. If you like seeing mathematical proofs all the time, subscribe to my channel, because that's all we do here. See you guys in the next video. Watch and learn.